This talk is all about various challenges in naming and authentication on the network. So names. Names for humans, they're not unique. Names ought to be unique. Mine is. I'm sure I'm the only Radia Perlman on the planet. And you don't have a single name. You have a different username on every site you visit. So for instance, your username at Amazon, your username at whatever. Sometimes if you're lucky, you can use the same username on more than one site, but if it's taken, you have to choose a different username. Email addresses. In a company, the first John Smith gets the email address john.smith. The next one has to be some variant. So when you're trying to send email to John Smith, how do you look in the org chart and you see 7 people with names like John.Q.Smith or Johnny Smith or J. Smith? How do you know which one to send to? And it's not so easy to delete spam if you know somebody else at your company has a similar name. If you know that the email was just to you, then anything that looks weird, you can just delete it. But if you know there's other people with a similar name and it might be unintentionally sent to them. So I have a great example of that. I got this email. Now, it meant nothing to me. There was this Excel spreadsheet full of random abbreviations. So of course I deleted it. And I got it several more times and I just kept deleting it until I got an email with that same thing, but in big letters at the top. It said, everyone has replied except Radia. And it's like, whoa. And so I reply all saying, I'm confused. What is this about? And one of them said, please check with SC3 team. I have no idea what SC3 team is, and gave me some email address. So I forwarded the whole thread to that email address and said, do you know what this is about? They said to ask you. And the person responded, if I understand correctly, you are asking about the availability of part number PNXHY in COV. And I replied, I have no idea what PNXHY or COV is. This entire email is totally mysterious to me. And then after a bit of background and stuff, they figured out that there is a different Radia at Dell, and it was not intended for me. It was intended for the other one, because Outlook is extremely helpful. Once you sort of start typing something, it suggests how to finish it. So imagine people with more common names. This must happen to them all the time. So that's names for people is a real problem. Website names. So we have DNS names, like, for instance, Dell.com. And there's some registry organization that administers each top-level domain. So a top-level domain is like .com, .org, .tv. There are over 1,500 top-level domains. And when you want to purchase a name, the website can choose which top-level domain to get a name in. If a name string in that top-level domain is available, usually the website can buy it. So for instance, my favorite website is rentahitman.com, which is a satirical website, but occasionally they get someone who actually thinks they can rent a hitman through that. And the people who run the website, if it looks like it's someone really serious about this, they turn it over to the FBI. So let's assume that a website has a DNS name. So the theory is beautiful. The website gets a DNS name. It gets a certificate, which is a digitally signed message that's by something that the client trusts. And the certificate says this DNS name has this public key. And with the magic of cryptography, the client can verify the signature on the certificate. And with more magic cryptography, the server can prove it knows the private key associated with the public key and the certificate. So everything is just wonderful. So the client wants to talk to X.com and says, hey, X.com, prove you have this name. the website sends a certificate, they do cool cryptography, and then they have a cryptographically protected conversation. Well, what could go wrong? In reality, usually the user doesn't start out knowing the DNS name, and instead they do some sort of search and get an obscure URL string. That's an actual URL string. It's not something any human should ever see, but yeah. So even if the user can look through the URL and find the DNS name, it still doesn't help. I fell for a scam recently. I wanted to renew my driver's license, and I knew it could be done online. So I did an internet search for renew Washington State driver's license, and I got search results. I clicked on the top listed site, and it just didn't occur to me that it wasn't the right one. And so I got something like this. Unfortunately, I didn't do enough screenshots before they closed this scam down, but it was something like this. And it probably said add, which I probably would have ignored because often the top thing that you want also pays to be the top thing. And so I clicked on it, and everything was as I expected. Look at this beautiful website. So you can click on renew your license, get a new license, etc. And this couldn't possibly be a scam because look at those pictures. The people are just so happy. So I clicked on renew license, and it asked me all the information I expected, like my license number, my address, and my credit card number. And I figured, oh, good, success. I have done that chore for the day. And I didn't think anything more of it, except for the criminals that put that website up were too greedy, and they kept charging more and more money on my credit card. And I wouldn't have noticed until a month or so later when I would have wondered why I didn't get a new license. But the bank fraud department called me and said, are these legitimate charges? And then I realized what must have happened. And I was not harmed in any way. The bank disallowed the charges, and they gave me a new credit card number. But it gave me a really excellent insight, which is that all of this cryptography does no good because it's kind of assuming that the human will know the right DNS name to go to, and that there's no reason to believe that. So don't blame the user. I claim I did nothing wrong. So scam sites can appear first after a search, either because they pay the search engine company or because they understand the ranking algorithm and can game the system. This particular scam at that time had several different names and for all 50 states. So there was something like WashingtonLicensing.org, IdahoLicensing.org, etc. Or motor vehicle license-washington.org, etc. And I think this scam has gotten shut down now. Now, it should be, once I realized it was a scam after the search thing, there should have been a way for me to report that it was a scam, but I don't think there is any such way to do that. So I'm surprised they figured it out and shut it down. So the site I should have gone to was www.DOL.departmentoflicensing.washington.gov. There's no reason why you should assume that the human should know that. So in my book on called Network Security, I wrote this little paragraph that after I wrote it, I thought, yes, this is exactly right. And I've seen it on quote boards. And I think everybody should take it to heart. Humans are incapable of securely storing high-quality cryptographic keys, and they have unacceptable speed and accuracy when performing cryptographic operations. They're also large, expensive to maintain, difficult to manage, and they pollute the environment. It is astonishing that these devices continue to be manufactured and deployed, but they are sufficiently pervasive that we must design our systems around their limitations. So user authentication, we'd expect a graph like this, that the more secure it is, the less usable, and the more usable, the less secure. But the industry has managed to settle here, which is minimally usable and minimally secure. So a human has zillions of username password pairs. How do you cope? Well, let's say that you follow best practices. Your passwords are all long and complex. Every site has different rules for how long the password must be, or the maximum length, the minimum length. Some of them make you change your password frequently. They say don't ever reuse a password, and don't use the same password at multiple sites or similar passwords. Obviously, this is not possible, but creative minds can make it worse. So password rules, they won't tell you what the rules are if you have forgotten your password until you're actually resetting a password. Now, if you forget your password and you go through all the annoying alternate proof of your identity, you're not allowed to reset your password to what it had been before, even though what it had been before would have been perfectly okay had you not temporarily forgotten it. Then these security questions. Who comes up with these? So this was an example, a set of security questions that I actually was presented with. Father's middle name. Nope. My father didn't have a middle name. Second grade teacher's name. I couldn't remember my second grade teacher's name when I was in second grade. Veterinarian's name. I don't have a pet. Favorite sports team. What's a sport? And then finally, my middle name. Well, luckily, I do have a middle name. It's Joy. So I typed in Joy, J-O-Y, and it said not enough letters. So ways to make things somewhat usable. You can use an identity provider. That means, like, if it gives you the chance to authenticate with Facebook, and you've linked your identity at site X to your identity at Facebook, then Facebook can vouch for you at site X. So, with the magic of redirects and cookies, Facebook can vouch for you at site X. So all you have to do is be logged into Facebook, and it can vouch for you at all these other sites. But if someone guesses your Facebook password, they can impersonate you everywhere. And if somebody breaks into the identity provider, all users can be compromised everywhere. So another thing you could do is use a password manager. Like browsers helpfully remember all of your usernames and passwords. I love it, and I use it all the time, but it's quite terrifying. Or you could maintain a file somewhere of all your username password pairs, and perhaps you could encrypt that file someplace. But in order to actually use it, you have to decrypt it, and malware on your machine can then steal your entire list of usernames and passwords. So another issue is PKI, still crazy after all these years. So PKI, I'll talk about trust models for PKI. So what is a PKI? It involves digitally signed messages signed by some trusted thing, vouching for what public key goes with what name. So a certificate says, I, the CA, vouch that this key belongs to the name Radia. And that's what we use when we use HTTPS. So the question is, who should be trusted to be the CA? So what's in our browsers today is the browser is configured with hundreds of public keys of CAs. Any of these organizations are completely trusted by the browser. So that means any one of these hundreds of organizations can impersonate anything on the internet to your browser. So this is how I think it should work. Instead of saying, oh, this CA is trusted, instead, it should be that a CA should only be trusted for a portion of the namespace. So the name by which you know me implies who you trust to certify that name. So if you know me as Radia Perlman Dell.com, you should trust a CA associated with Dell.com to certify the mapping between that name and a public key. Or if you know me as Roadrunner279 at socialnetworksite.com, you would trust the social network site to to associate that name with a public key or a credit card with a particular bank. Whether or not those names refer to the same carbon-based life form is irrelevant. So we need to do this, we need a hierarchical namespace. And yes, we have it. DNS is a hierarchical namespace where each node in the namespace represents a CA that can certify names in that namespace. So with this model, if everyone would have to be configured with the key of the root CA, and then the root CA would certify the key of .com and so forth, and you would just need to follow the namespace down in order to get the mapping between a name and a key. But the problem with that model is the root can impersonate everyone. So here's the model that I recommend. It's kind of like the top-down model with two enhancements. One is up certificates and the other is cross certificates. I'll explain what each of those are. So an up certificate says not only does the parent CA certify the key of the child CA, but the child certifies the key of the parent. So why is this important? Well, the reason is that your trust anchor, that means the thing you're configured with, doesn't need to be the root. So for instance, an organization like Dell.com could configure all of their resources to start at Dell.com. And to get to a name within Dell.com, you would just follow the downlinks within the Dell.com namespace. To get to names outside, then you'd have to go to the parent CA until you get to an ancestor of the target name and go down. And now the root can't impersonate everyone within a particular organization. The CAs that need to be trustworthy are only CAs associated with that organization. So it doesn't matter how malicious all the other CAs might be, it won't impact authentication between things in that organization's namespace. So another thing that's useful is cross certificates, where any of the CAs can certify any other CA's key. And there's two reasons for that. I'll have slides on each one. One is so you don't have to wait for the whole world's PKI to be created before you can start using this. And also, if you don't trust some of the CAs, you can bypass the hierarchy with a cross certificate. So here you can have two organizations that just create their own little PKIs, and then if they cross-certify each other's top CA, then everybody in this namespace can find names and keys for everyone in that namespace. And also, if for some reason the guys in this little subtree don't trust the root or don't trust that, they can create a cross-link over here, and therefore everyone in this subtree will follow that cross-link and then go down instead of going up. So another thing to rant about is certificate expiration. Why do certificates have expiration dates? Well, you might think if someone steals, Bank of America's private key, you don't want that certificate to last forever. But you can't rely on the expiration date in the certificate because you can do a lot of damage in a few hours, and the expiration date is typically, months. Is it to annoy and frighten users where you click on something and it mumbles something about expired certificates? This is not secure. Yes, it does annoy and frighten users, but was that really a goal? Google has announced a policy that it won't accept any certificates that have more than a 90-day expiration. And that's way too long for safety and super annoyingly often. So the only real solution is a revocation mechanism, where as soon as someone decides a certificate should be revoked, that someone has lost their private key or thinks it might get stolen, you have to be able to revoke your certificate. And the industry has known for decades how to do revocation. There's basically two mechanisms. One is a certificate revocation list, which is posted that says all the revoked certificates, or OCSP, Online Certificate Status Protocol, which is where you can query some server and say, hey, is this certificate still valid? But this, even though they know how to do this, revocation is not really well deployed. If it were well deployed, we wouldn't need to put expiration dates in certificates, unless the problem we're solving is guaranteeing a revenue stream for commercial CAs. And indeed, that might be why the expiration date is there. So I heard somebody claim that distributed identities using blockchain solves the identity problem. And my thought was, really, what do you think the identity problem is? What do you think blockchain is? And why do you think it would help? So what is blockchain? Well, one way of thinking of it is that it's a magic thing that solves everything, especially if it has anything to do with security. But a more realistic thing is it's just an append-only database, world-readable, stored and maintained by lots of anonymous nodes expensively. So what is this distributed identity using blockchain thing that was proposed fairly recently? I've simplified the concept down to what it really is conceptually. So names will be hierarchical, with the top being which namespace, just like a top-level domain in DNS names. So it'll be namespace ID : rest of name. So each namespace uses its own independent blockchain. Within the namespace, names are first come, first served, nobody in charge. So the string is now completely meaningless. So what you do is you look through the blockchain for all the strings that have been claimed, and you just find a string that hasn't been claimed, and you decide that's going to be your name, and you put that and a public key on the blockchain. So what subset of identity is this solving? It's only obtaining a name and asserting its public key, but getting a unique ID is not a problem. We have lots of unique IDs. And public blockchain is very expensive, among other issues, and names become meaningless strings, even more so than they are today. And it doesn't say how to map this meaningless string to a DNS name, so you can use DNS to get an IP address to reach the thing. It does avoid CAs mapping names to keys, because if whoever claims a name also puts a public key on the blockchain, and in theory, the blockchain can't be modified, you don't need certificates, but you'd need some sort of trusted thing to certify the mapping between the meaningless string name and who you actually want to talk to. And since the name is a meaningless string, you could have just used public keys as your identifier. They're unique and they're meaningless, just like this other name would be, and then you can bypass certificates and blockchain entirely. So what doesn't it solve? Mapping between the name and what the human actually wants to talk to, mapping between this syntax and a DNS name so that you can find the thing if by some miracle you know its name, and the user remembering their own private key or other credentials. So I mentioned this in a talk once, and someone said, oh yeah, they solved that. And I said, really, I can't imagine. How have they solved the idea of what happens if a user loses their private key? And yeah, so how did they solve this revocation thing? And so he showed me a spec that says, saving the private key is essential. You can't lose it. All access and control will be relinquished. Don't lose a private key, please. And so the solution is to ask users very nicely not to lose their key. So nothing is quite right today. Names really are just meaningless strings. The current system of browsers trusting hundreds of CAs for everything is extremely insecure. The current system assumes the human magically knows the DNS name they want to talk to. Human authentication is unusable and insecure. Blockchain and distributed identities won't help any of these things. And it's amazing things work as well as they do. So final rant, some hype to ill-defined thing suddenly appears, like blockchain, and people don't want to miss out because it might be the next big thing. And so they want to do that. And so I tell people, no, don't say, let's do some buzzword. Instead, look at the problem you want to solve. Look at various ways of solving it. Consider the technical pros and cons, and then build the best solution. So I said that once in a talk, and someone said to me, oh, that sounds good. I would love to do that, but my manager really wants me to use blockchain. So I said, fine, do what I said, consider all the various approaches, build the right thing, and then just tell your manager you're using blockchain. They'll never know the difference. So thank you. That's it, and I'm ready for questions.